Welcome everyone. In this video we are going to solve one more problem related to the force vectors, which is problem number 6 from the chapter of force vectors in the book of engineering mechanics, the statics part by R.C. Hibbeler. In this problem we are being asked to determine the magnitude as well as the direction of the resultant force caused by these two forces F1 and F2 which are acting on this member. The direction should be measured clockwise from the positive u-axis. So let's solve this problem. So let's consider the member on which these forces are acting. The two axes, u-axis and v-axis, are given. Both of these axes are making an angle of 75 degrees with each other in this direction. The F1 force of 4 kN making an angle of 30 degrees from v-axis in clockwise direction. The total angle between u and v axis is 75 degrees. So on the other side it will also be 75 degrees. Therefore the remaining angle would be 45 degrees that the F1 force is making with the u axis. Another force F2 of magnitude 6 kN is making an angle of 30 degrees with the u axis in clockwise direction. First, we are going to determine the magnitude of the resultant force. So the magnitude of the resultant force will be calculated using Cosine Law. If you are familiar with the Cosine Law, that is, the resultant force is calculated by the formula F1 square plus F2 square plus 2 F1 F2 cos theta, that all is under root. Obviously the F1 and F2 are the magnitudes of these two forces, but the theta angle that we should be knowing what is that. That is actually the angle between these two forces, and in this case the angle between these two forces is 75 degrees. You might have seen another formula with negative sign for this term, where the angle will not be the angle between these two forces, but the angle that the F2 force is going to make with F1 if we form a parallelogram. But I make it simple. By just using the angle between the two forces, we can directly calculate the magnitude of the resultant force. So here we just put the values of F1, F2 and theta. So on putting those values, we are going to get the magnitude of the resultant force as 8.03 kilonewton. This is one of the answer. The next thing that we are being asked is the direction of the resultant force. Now for the direction of the resultant force, we should form a parallelogram where we can see where would be the direction of the resultant force. So to form the parallelogram, we have to place the second force with the first force. I mean to say, the tail of the second force will be placed at the head of the first force. So by doing so, we are going to get this. But hang on, we need to know the angle between these two. So for that I have to make use of the concepts of the geometry. That is, if I extend this line, so whatever angle this will be made, the same angle would be formed with F1 and F2 when F2 will be placed at the head of the F1 force. So how we can now determine this force? So if this angle is 30, the opposite angle will also be 30. It means this angle will also be 30. Now how about this angle which is left now? For that we have to utilize this whole angle which is being formed between u and v on the other side. Like on this side, the angle between u and v is 75 degrees. So on this side, so we know that the total circle is of 360 degrees. So I write here the total is 360, where we have two portion of 75 degrees, one on this side and one on the other side. So 2 multiplied by 75, we have two more portion, but we don't know the angle of that. Let's say the angle is x degree. From here we will have the value of x degree, which is actually this angle. So on doing calculations, you're going to get this x as 105 degrees. So this angle is 105 degrees. So it means this will also be 105 degrees. So the total is 105 degrees. If I subtract 30 degree from there. So we will be left with 75 degrees. So it means that this angle, the total angle from here to here, is actually 105 degrees. Therefore, the angle which F1 and F2 are making over here has a magnitude of 105 degrees. I mean to say this angle is actually 105 degrees. So according to parallelogram law, the diagonal of the parallelogram will be the resultant, I mean this diagonal. So this will be the resultant force. Now we are going to utilize this triangle to determine the direction of the resultant force, which is made clockwise from the positive u-axis. Now how we are going to do that? For that we need to know the total angle, and let's say the total angle is alpha. The total interior angle is alpha, and if you look at this triangle where we have this side as f1, this side as f2, and this side as the resultant, so we know the magnitude of all three sides, then we can simply calculate this alpha using sine law. So let me separate this triangle so that you can have better understanding of applying the sine law. So this angle is of our interest. This angle is 105 degrees. This is resultant, which has a magnitude of 8.03 kilonewton. We have this side as F1. We have this side as F2. So by applying sine law, that is the sine of alpha, the angle which is of our interest, will be divided by the magnitude of the opposite force. So the opposite force of this alpha is actually F2, so 6 will be divided to that. Now we know this side, which is 105 degrees, the opposite side is resultant force. The magnitude of that is also known, so simply apply that. Sine 105 degrees divided by the resultant, which is 8.03. So on doing calculations, we will get the value of alpha as 46.22 degrees. Now if we come back to the previous figure where this was the alpha, and now just we have calculated the value of alpha, which is 46.22 degrees. Now since we are interested in determining the direction of the resultant force, which is measured clockwise from the positive u-axis, so this is the positive u-axis. Now the angle from F1 to U is 45, and the angle from F1 to the resultant is 46.22. So if we simply subtract 45 from 46.22, we are going to get an angle of 1.22 degrees as the angle which is measured clockwise to the resultant force, and that's the one which we are interested in, and that's what we have got. So this is all from this video, where you have learned about calculating the resultant force when the two forces, their directions are given. But this case was a bit different from the previous that we have solved so far, because in previous cases the axis was simply given as x-axis and y-axis, but here the axis was u-axis and p-axis. The angle between those two axes were given. Using cosine law, we have determined the resultant of these two forces, and using sine law, we have determined the direction of the resultant force measured clockwise from the positive u-axis. That's all from this video. Thank you for watching this video. I hope to see you in next coming videos. Till then, bye.